Hello guys, good evening to all. In today's class, what we are going to learn is how to solve the problem using Hamming error detection and correction method. So I request you people, if you are watching this video for the first time, so we have completed one more video, basic introduction to Hamming error detection and correction method. There we have discussed the introduction about why we need of the error detection as well as the error correction. If you don't see that video, please go through that video, then come back here, right? So in this class, what we are doing is, so for the given problem, we are going to identify, right? So solution, right? So for example, if we consider this question, the question may be asking like this: encode the, right? The question is look like this: encode the 7-bit Hamming code for the data bits 1001. So what is the meaning of this one is, they have given the data bit value, nothing but the message bit value, right? So we need to find out the, right, Hamming method 1. So method 1 is nothing but the, as we discussed in the previous video, so method 1 is only for the transmitter part. They will be giving some message information or data bits. For the data bits we need to append the extra information. That extra information we are calling as the parity bit value, right? Now as per the given question, if you observe here, the number of message bits are given as the 4 message bits value, right? So see how it is the 4 message bit value means, if you consider this is the message bit value they have given, so this is 1001. So number of message bits are 4 bit values, right? So what is the transmitter code word is the length of the message bit value as well as the length of the parity bit value, right? So encoding means for the our original information we are going to add the extra bit, right? So now what is the thing, first step we have to do is we need to identify how many parity bits are required, nothing but how many extra bits to be added for the question, right? So now one more important point to remember here is, for example, in this question the length of the message bit is 4. If you observe here, the length of the message bit here 4. So depends upon the length of message bit, here you may be getting the parity bit value, it may be 3 or it may be 4 or something value. Suppose in second question, in some other questions, if the message bit is something 10010 something, so in that case you may not be expecting the same parity bit value. So what you have to understand at this point of time means, depends upon the length of the message bit or data bits, the number of parity bits will be varying, right? Fine. Now what we will try to do is, we will try to find out the, how to find out the parity bit values. We'll try to find out parity bit values. So to find out the parity bit value, the formula is 2 power p greater than or equal to m plus p plus 1. So what is the formula is 2 power p greater than or equal to m plus p plus 1, right? Where m is nothing but the message bit value, p is nothing but the parity bit value, right? M is nothing but the message bit value, p is nothing but the parity bit value, right? So by substituting the parity value in this formula, we can able to identify how many extra bits to be added. So nothing but the parity bit value. So if you observe here, we know that only we have the message bit value, right? So see that we know that what is the message bit value is 4, but here if you observe this, we don't know what is the parity bit value, that we need to find out, right? We need to find out the parity bit value, right? So how to find out the parity bit value means, I mean how many number of parity required is, right? So by using of trial and error method, we are going to identify how many parity bits are required. Suppose this is the formula, right? So let us assume p value equal to 1. Initially I don't know, right? But thing is that you can consider any p value, right? What I'm trying to say here is, you can consider any p value, but it should satisfy this condition. What is the meaning of this LH side, left hand side, this is the right hand side, it should satisfy this particular condition. If that particular condition is satisfied, then it means that those many number of parity bits we need to append with the message bit or data bit values, fine, right? So for the first time, we don't know what is the actual value of the parity bit, right? For example, I'm considering in trial and error method, let p equal to 1, right? Let p equal to 1, just substitute in the formula. 2 power p means 2 power 1 greater than or equal to, what is the m value? So remember that m value is always constant. As per the given question, the m value, the size of the m is 4-bit value, right? Now what is the value we have considered p value in trial and error method? 1, right? Right. So m plus, what is the p value? 1 plus 1. So now if you observe here, 2 is greater than or equal to 6. Is this condition is satisfied? No, right? The LHS condition is not satisfied with the RHS condition, right? So means, what is the meaning of this one is, we should not consider number of parity bits equal to 1, right? So condition is that it should satisfy greater than or equal to thing. If it is satisfying this condition, those many parity bits we need to consider. So for example, in trial and error method, I consider p equal to 1. This condition is not satisfied. Okay, now what we will try to do is, we will consider one more p value. So for example, in this time we will consider the p equal to 2 value. Just again you substitute in the formula, right? Substitute in the formula. So see, 2 power p greater than or equal to m plus p plus 1, right? So here I am substituting the value, let it be 2 power 2 greater than or equal to m value is always constant, right? So what is the p value we have considered? Let p equal to something we have considered here is p equal to 2, right? So that we are substituting here. Fine. So greater than or equal to 2 plus 1. So what is the meaning of this one? 2 power 2 means 4 greater than or equal to 7. Is this condition satisfied? No. What is the meaning of this one? We should not consider the 2 parity bits because this condition is not satisfied. Fine. Now what we will try to do is, we will consider the one more bit value. This time we will consider the p equal to 3. Now what is the thing p equal to 3 means? Just to substitute the value 2 power 3 greater than or equal to, m value is always fixed. What is the p value? Here we have taken at this time 3. So plus 1. So what is the condition we got? 8 greater than or equal to 8. Now see that 8 is not greater than 8, but it is equal to 8, right? So this condition is satisfied, right? Now how many parity bits we need to consider? 3 parity bits we need to consider, right? So how many extra bits to be appended to the message information is the 3 bits that we need to add. So see that the first step is, we need to find out how many extra bits or parity bits that need to be added to the original message information at the transmitted part, right? So after finding of the parity bits are completed. Now as we said earlier, the total length of the transmitted code word is nothing but the combination of the message bit value, combination of the parity bit value. As per given question, the number of message bits are 4. After finding in the formula 2 power p greater than or equal to m plus p plus 1, we got p value equal to 3. So total length of the transmitter section is the 7-bit value, right? So what is the total length of the transmitter information? It should consist of the 7-bit binary number, right? So it should consist the 7-bit binary number. So this is simple to solve this problem. So after finding the number of parity bits, so just for understanding, I am making the table like this, right? So how many total, what is the length of the transmitted sequence? 7-bit, right? So for that reason I am writing bit positions, right? So always remember that we will write the number from this direction to this direction. Why means, if you are writing the binary formula, if you understand binary representation, r power 0, r power 1, r power 2, r power 3, something we used to write for the integer part, right? The same direction we need to consider here. Means we are starting from 1, 2, 3, 4, 5, 6, 7, right? So why we are writing up to 7 means, the total length of the transmitted code word is only 7 bits. So for that reason we are writing the 7 numbers, right? Once it is completed, now what we'll try to do is, we will write the binary representation for the particular number. So here we have the shortcut, right? If you are writing the binary number for decimal number 1, we can write 1, or we can write 0, 1, or we can write the 0, 0, 1 also, right? But here we will consider one simple thing is that, so go to the maximum number. What is that maximum number value? 7 is the maximum number value, right? What is the binary number for 7? The binary number for 7 is 1, 1, 1, 1, 1, 1, right? So triple 1 is nothing but the binary number. Now if you are representing any binary number, we will represent with the 3-bit number. So what I'm going to tell here is, so if you are going to write the binary representation for the number 1, you just write 0, 0 and something, 3-bit representation. Simple thing. Find out the maximum number, find out the binary value. So those many bits you consider here. It is not mandatory. just for making the equal number of bits we are writing, that's it, right? So now here what we are going to do is, right, we have written the binary representation. See, for each and everything we are writing the binary number 7, for 6, 5, 4, 3, 2, 1 we are writing the binary representation. Now what we have to find out is, remember that this is the value we need to find out. This is some binary value. These are all the binary values. So this is consist of the total length of the transmitted code word. In this total length of the transmitted code, somewhere you will be having the message bit value, in somewhere you will be having the parity bit value, right? Somewhere you will be having the message bit value, somewhere you will be having the parity bit value. Fine, I think you understand up to this, right? Now what we will try to do is, so out of these 7 bits, some bit location may be message bit, some bit location may be parity bits. So what I am trying to say here is, suppose if you consider these 7 bit values, right? So starting from 1 to 7, so this might be your message bit location, this might be your message bit location, this might be your message bit location, right? Just for example, now out of this we have the 4 message bits, 3 parity bits, right? So we need to identify in which location, right? Try to remember in which location we need to place the message bit as well as the parity bit. It is not like something straight away to place the message bit or parity bits. Now the second step is that we need to find out what is the location of the message bit, what is the location of the parity bits out of the 7-bit representation transmitted code, right? But if you observe in real time, we don't know or we cannot able to find out where we need to place the message bit value. What I'm trying to say here is, out of 1 to 7 bits, we don't know which location is belonging to the message bit value, but we can able to find out what is the location of the parity bit value, right? So thing is simple. If I can able to find out the location of the parity bit value, right, so remaining all bit will be message bit values, right? Suppose for example, say this is my P1 value, 3 parity bits, this is my P2 value, this is my P3 value, right? Then what is the empty positions here? Empty positions are nothing but the message bit value, right? That's it, right? So here we can able to find out the location for the parity bits. After finding the location of the parity bits, right, straight away we can write the location for the message bit. Now how to find out the location of the parity bits out of 1, 2, 3, 4, 5, 6, 7, right? So as we said in earlier, we have the formula, right? Binary representation. What is that? R power 0, R power 1, R power 2, R power 3, something, right? So what is the binary value? Binary for number system, R value equal to 2, right? Because in binary number system we use only 2 digits, one is 0, another one is the 1, right? Just substitute the value, 2 power 0, 2 power 1, 2 power 2, 2 power 3, something. So what is the value? 1, 2, 4, 8, 16, something it will go. Now what you should understand from this one is, so this is the place where we need to place the parity bit value. Suppose as per the question, how many parity bits we have? 3 parity bits. What is the location of the parity bit should be? The location of the parity should be first location, second location, fourth location. Suppose in the next question, suppose we might be having the number of parity bits equal to 4. In that case, what is the location we need to place? First location, second location, fourth location, 8th location. If you have the 5 parity bits, then this is the location we need to place, right? I hope you understand. So we have the way to find out what is the location of the parity bit by same this formula. So this places only we need to provide the parity bit value. Hope you understand this one. Now what we will try to do is, we will place the location of the parity bits. Once it is done, right, so once it is done, then we are going to place the message bit values, right? Fine. Now see that this is the location of the parity bit as well as the message bit value. See, what is the location of the parity bit value we have discussed? The location will be 1 to 4. See that I have placed in the location first parity bit, in the second location second parity bit, and in the fourth location third parity bit, right? So this is completed. So if it is completed, then here we have the vacant positions, right? So here this is a vacant position, right, that we are going to replace with the M1. So we started this direction, so we are filling in this direction only, right? We started this direction, so we are filling in the direction only. Fine. So this is M1. After P3 we have this empty location M2, M3, one more is the M4 is the location, right? First what we have done is we identify the how many parity bits are required. After identifying the number of parity bits, we can able to identify the location of the parity bit. The location will be 1, 2, 4, 8 something. After finding the location of the parity bits, the remaining bits are nothing but the message bit value. I hope you understand all these steps. Now what we will try to do is we will try to find out the final Hamming code. But see that, so final Hamming code is nothing but the consist of the 7-bit number, right, as we said. So finally we need to find out these binary values, right? So message bit plus parity bit. But if you see that in the given question they have given data bit value or message bit value, what is that bit value? They have given 10001 is the value they have given. So see that what is the meaning of this one is, I know M1 value, I know M2 value, I know M3 value, I know M4 value, right? Just we can write it, right? The reason is that in the given question itself they have mentioned the M1, M2, M3, M4 values, right? So straight away we can write what is M1 value, this value 1, M2 value 0. See this location only we are placing. M3 value again 0, this is the M4 value, right? So we have placed the message bit value successfully because in the given question itself we have the message bits value. Now thing is that what we have to find out, we know that message bit values are 1, 0, 0, 1. Now what about the parity bit value? Means this value we don't know at this point of time, this value, right, this we need to find out. So this question mark represent at this point of time I don't know what is the P1 value, I don't know what is the P2 value, I don't know what is the P3 value, right? I hope you understand, right? Now final thing is that in the receiver transmitted code means, so what is the value will be getting, this value as it is, whatever the information we have that I'm going to write 1, 0, right? So 0, this is unknown value at this point of time, 1, then this is unknown value, this is 1 value. So this may be either 0 or 1, that we need to find out now. Once if we can able to identify these unknown value, cross value, then our problem is completed, right? Now what we will do is we will try to complete the, right, now we will try to find out the parity bit value, fine, right? Now how to find out the P1, P2, P3? P1, P2, P3, why means because I have only 3 parity bits that I am trying to find out. So what we have to find out here is we need to find out the value of P1, value of P2, value of P3, right? So we need to find out value of, excuse me, right, this is the information, right? So we need to find out value of P1, value of P2, value of P3. This thing we need to find out, right? The same slide here I am giving, right, for understanding purpose. Yeah, fine. Now see that we have the P1, P2, M1, P3, M2, M4. But before going to find out the P1 value, P2 value, P3 value, we have some important point to be understand. If we consider P1, so what is the value of P1? So what is the value of P1 here? 0, 0, 1, right? So 0, 0, 1. In case of you come to P2 value, what is that value? P2 means what is that binary value? 0, 1, 0. If you have something called as the P3 value means what is the answer is 1, 0, 0. If you have the value P4 means what is the value? 1, 0, 0, 0. See here from this why I am writing like this means from this you need to understand one common important parameter or point. By using those simple kind of logic we are going to find out the P1 value, P2 value, P3 value, right? For example, see in consider P1 value we have only single one, remaining all values will be 0. If we consider P2 also we have the only single one, remaining all bits are 0. In case of P3 also only 1 bit value is 1, remaining all bit values are 0. In case of P4 also 1 bit value is 1, remaining all bits values are the 0. What do you mean by this? What I am trying to explain here is for any parity only one location will be there as 1, remaining all bits will be 0. By using this logic we are going to find out what is the P1 value, what is the P2 value, what is the P3 value we are going to find out, right? So based on this logic we are going to identify what is the P1 value as well as the P2 value as well as the P3 value, right? Now we'll start to find out the P1 value. Once it is completed, now we'll go with the P2, then we'll go to find for the solution for the P3 value. See, then one more point to remember is, if you are going to compare parity bit, remember this is an important point. If you are going to compare the parity bits, we need to compare parity bit with the all other message bits. Means P1 should be compared with M1, M2, M3, M4 only we need to compare. Remember that parity bit should not compare with the parity bits. Parity bit should always compare with the message bit only. What do you mean by this? Suppose if you want to find the solution for the P1, let it be, right? So P1 should compare with the M1 once it is completed. Again P1 should compare with the M2 once it is completed. Again P1 should be compared with the M3 once it is completed. Again we should compare with the M4. Try to remember this logic. Always parity bit should compare with the message bit. And then one more point I explained is, in one location only we will be having the 1, remaining all bits value will be 0 in case of the parity mechanism, right? So it means that, right, so what is the meaning of this one is, right, if you observe here in P1 value, what is the binary value in P1 value? 0 0 1. It means in only one location we have the value 1, in remaining places value will be 0, right? So see that if this bit is 1, right, it should be compared with the, for example, M1. If you are comparing with the M1, you just check whether here the first bit is 1 or not. Just here the LSB bit position is 1, here also you check whether LSB bit is 1 or not. If it is there, if it is matches, then we need to write the corresponding message bit value, right? As per the given question, this is the message bit information, right? That value we have to write. What is that value? Initially, if I want to find out the P1, I don't know this P1 value initially, right? So when you are comparing P1 with M1, this location, you just check the LSB location. In message 1, do we have the LSB bit value is 1? Yes, these two are matches. If matches, you just write the what is the corresponding message bit value. What is that value? 1 is the value. Now this is completed. Now what we have to do is P1 should be compared with the next message bit M2. Now see that. So again here same bit value. Here we have the 0, LSB bit value equal to 1. So compare with M2. Do we have in LSB bit value 1? Yes, this is also 1, right? You don't need to bother about these remaining bits, right? Try to remember, you don't need to bother about this one. You just check with that LSB bit is there 1 or not. It is matching or not. If it is matching, we should write that corresponding message bit value, right? If it is not matching, what we have to do? Just we are skipping. We are going to compare with the another message bit value. So here also both positions are matching. So what is that message bit value? 0 is the message bit value, right? So comparison with the M2 also completed. Now what we will do? We will compare with the M3, right? P1 should be compared with the M3. Now check that, do we have the LSB bit is 1? Here you need to understand carefully. Here LSB bit value is what? 0. Here what is the LSB bit value? 1. Now both are matching? No, right? So if both are not matching, we should not write this value. Again I am repeating, we should not write this value because it is not matching. So in this case what we have to do is we need to skip the value. That's it. Means here you should not write any value. Remember, this value we should not write any value. Now what we have to do? P1 should be compared with the again. Then one more is the M4, right? So P1 should be compared with the M4. Just compare it. Do we have LSB 1? Yes. That means it is matching. So matching means what is the answer? The answer value is 1, right? So that now see that this is the answer, we got something 1. Don't forget about this one. I think it is not the correct representation. So 101, right? So 101 means what is the value? For example, in the given question they have mentioned something called as the use the even parity mechanism. Even parity mechanism means if you count the total number of ones, the total number of ones should be even, right? If it is even, satisfies, then you write the output as 0. If it is odd, then you write the output as the 1, right? So now just count the total number of ones, even. So what should be the unknown value here? We need to keep 0. So what is the answer for the P1? 0 is the answer. Now you might be having the doubt that if I keep here 1, what will be happen, right? So as per the given question, suppose they have asked the even parity, but you just count the total number of ones, 1, 2, 3 ones. 3 1 means odd number, but what we are trying to keep? Even number. So it is wrong, right? So always even number means the count should be even, right? It is already even, so we are keeping here 0. So what is the P1 value we have find out? P1 equal to 0. Now what is the remaining thing we have to find out? P2 value, P3 value we need to find out, right? So now we have obtained the 1 value of the P1. Now what is the pending thing? P2 is pending, P3 is pending. Now we will see how to find out the P2 value, right? So we have got this answer is P1 value equal to 0. Now I am going to find out the answer for P2, right? We are going to find the answer for the P2. Initially I don't know P2 value, right? Right. In which location we have the 1 in P2? Second bit location, right? So this logic you apply for the all other message bit. P2 should be compared with what? M1, right? Do we have the second location 1? Yes, right? Second location is the 1, right? If it is present, then what should be the value we need to write? That corresponding message bit value, right? So what is the answer here? 1 we need to write out. So once it is completed, again P2 should be compared with the P3. The second bit is matching? No, right? No means, so what, sorry, P2 should be compared with the M2, right? No, always we should compare parity bits with the message bit value. So do we have the second bit value 1? No, not matching means we should not write this value. Done. Again you compare P2 with the M3. After comparing P2 with M3, is second bit is matching, right? Right. If it is matching, we need to write this value. What is that value? 0 is that value. Again P1 should be compared with the M4, right? So is the second bit we have the 1? Yes. What is that value? 1. So we need to find out this answer, right? So what is the answer here? So it is already even number. So we just keep the 0 according to the even parity. So now what is the P2 value we have obtained? P2 value also 0, right? Now what is the pending thing? We need to find out the P3 value, right? So always remember that when you are comparing parity bits, that should be compared with the message bit value. In this case I am going to find out the answer for P3. Initially I don't know what is the P3 value, right? P3 should be compared with what? Message bit value. Is it in matching? In third location we have the 1. Do we have 1 in third location? No, no means we should not write this value. That's it. Now again compare P3 with M2, right? So comparing M through 8, in P3 we have this location 1, right? Do we have this location 1? Yes. If it is yes, what is that value? 0 is the value, write down here. Again compare P3 with the M4. Do we have this location 1? Yes. What is that answer? Right? 1. Now what is the answer we got? 0, 1. So just count the total number of ones. Total number of ones are what? Odd number, right? 0, 1 means count the total number of ones. We have single one, nothing but the odd number. Now suppose if you keep 0 here, what will be happen is 0, 0, 1 again become the odd number. It is not the even parity. So what the answer here is, we need to write 1. If you write 1, it will become 1, 0, 1. Nothing but counting of 2 ones. 2, 1 is nothing but the even number. Now what is the P3 value? 1, right? So we have find the P1 value, P2 value, P3 value. What is the value we have find out? So we obtain P1 equal to 0, this P2 value equal to 0, then P3 value equal to 1. Now see that as per the given question we have already message information. What is that value? 1, 0, 0, 1. What is the parity bit value? 1, 0, 0. Now see that we know that 7 bits, these all the 7 bits are the combination of the message bit value as well as the parity bit value. This is the first type of question you might be getting in exam point of view or competitive exams, right? So here we have the two types of question as we discussed in the earlier video. One is transmitter part question, another one is the receiver part question. This question is belongs to the type 1 question, nothing but the transmitter part. In transmitter part, whatever the original information we have, so for that we are adding the extra bits. Those extra bits are called as the parity bit. In next class we will try to solve problem at the receiver side, right? Thank you.